Dijana Likar is the head of the Energy Department in IECE. She has developed research and innovation projects for improved application of renewable energy sources, energy efficiency of residential buildings, industrial plants, innovative multi-criteria methodological approaches for the evaluation of projects in energetics, training programs for technical, economical and regulatory aspects of using energy in technical designs. He has achieved complex energetics, EER, environmental, economy and regulatory demands in energetics. And Dijana is an author of a number of international conference papers and presentations. We have worked with IECE in a number of projects, including BIMCert, which is looking at the digital transformation of energy projects and making sure the skills are there, and the utilising and harnessing the innovation skills of the IECE team. Unfortunately, as we said, Dijana can't join us, but hopefully I will do our slides justice and be able to cover them and look at what Dijana uses in our projects as innovation foundations and models, specifically towards the hydrogen transition and the zero carbon transformation. IECE is the Institute for Research in Environmental, Civil Engineering and Energy in Skopje in North Macedonia, and works on three key pillars: research and innovation, education and consultancy, and across sectoral technological fields with a specific focus on integrated and efficient management of resources. All of the specifics of IECE's experience is in establishing and supporting collaborative partnerships between academia and industry in the COIN model through common research and innovation programs, using the All4 R&D program, research project and sustainability leadership. As we said, we have worked with IECE over the last 4 years and have moved forward with them on our innovation proposals. The IECE research project and demonstration study, the innovative model for development of learning organizations through knowledge management and intellectual capital, submitted in 2020 to International Knowledge Management Awards, has been selected as one of the 10 finalists across Europe and is expected to go through to the final on the 4th of December 2020. And we hope and wish Dijana and all of her team in IECE all the best of that. And it's a fantastic opportunity for them to showcase the work they're doing. Research and innovation energy sector, more specifically, the energy efficiency, utilising renewable sources and clean energy nexus are within IECE's fields of occupation. The nexus approaches are proven to have a positive effect on efficient resource management, being one of the key pillars of the Energy Roadmap 2050. Hydrogen is included in IECE's research programme, including in particular not just the work they've done with us on Hazel, but also in generation sources and model, specifically water, using that as the materials nexus, and in coupling with RES for their optimal integration in the power grid, complex multi-criteria approaches, algorithms and software, and for multi-source energy system stimulation, evaluation and decision making. The research and innovation in hydrogen technologies within the EU decarbonisation agenda. The hydrogen strategy for climate neutral Europe includes promoting new ways of research and innovation. They are key to the centre of moving the agenda forward. To ensure a full hydrogen supply chain, not just the green hydrogen as the destination, but all the different transition energy sources, blue, grey and brown hydrogen, and that further research is needed, and that's where IECE will be working. On that generation side, which will include upscaling of existing and the development of new and more efficient and cost-effective sources, materials and methods for hydrogen production. Secondly, infrastructure will need further development for distribution, storage and dispensing hydrogen at large volumes. Being able to use the hydrogen where, when and how you need it and get it to the opportunity of utilisation. Third, large-scale end-use applications need to be further developed, notably in that lower-hanging fruit. The harder decarbonised sections include industry and transport and making sure the greater uptake is taken there. And finally, further research is needed to support policy making in a number of cross-cutting areas, particularly to enable improved and harmonised safety standards. The new hydrogen exploratory fields that we're working with IECE and our other partners across Europe is based on the World Energy Outlook, that special report, July 2020. Hydrogen technologies are one of the 6 strategic opportunities in technology innovation needed for the green recovery of the world economy. The production side includes improving water cycles and hydrogen generation, utilising wastewater within the hydrogen production, closing the loops of water, energy and materials, cross-sector in the circular economy, and producing that clean energy needed to decarbonise our end journey. Cost-effective and environmental friendly methods and materials applied for green hydrogen generation, and systematic inclusion of hydrogen energy networks. Sector coupling hydrogen with other renewable energy sources, using hydrogen as that catalyst, as that threshold energy optimization to integrate power into the grid, and multi-criteria optimization models, accountability, reliability, availability, cost, and environmental aspects. The new hydrogen exploratory fields at the production site. We'll hear from this later on when Rose is on from Pure Energy Centre, but wastewater to hydrogen, the fuel of the future. How can we take 2 steps in wastewater cleaning and move it into 1 step so you clean the water and produce energy at the same time? That's currently involved in a number of different projects across Europe, and I know Northern Ireland Water are looking at that at the minute with the assistance of the different energy departments in Northern Ireland. How do we clean up transport and use dirty water as that vector? Potentially, wastewater makes a readily available, attractive, and low-cost stream of material from which hydrogen could be produced. IECE are working with our partners in INSA and working with our other GenCom partners looking at this. Dr. Lionel Estelle in INSA Rouen is looking at wastewater as the opportunity for that electrolyzer to produce the energy. And as I've said, move those 2 steps into a 1-stage transition. Lionel and others are looking at numerous different approaches being explored and developed that can reduce the environmental impact of wastewater treatment while increasing the production of hydrogen. And then also looking at where wastewater may ultimately prove to be the clean fuel of the future. And as I said, INSA Rouen and the team there with Lionel and Estelle are looking at that and looking how under our sub-program on one of the work projects, looking how we take that the next step. Other new hydrogen exploratory fields at the production side. Water treatment companies also exploring other approaches to generating water. Scottish Water have announced earlier this year is exploring the use of electrolysis to produce hydrogen oxygen from its wastewater stream. Preliminary results have been confirmed feasibility of the methodology applied, and they're now taking that to the next stage. The win-win strategy, since oxygen is used for ionization, the disinfection of water in the tertiary phase of treatment, it requires a lot of energy to create ozone. Then the oxygen produced during CO2 or H2 generation can be used to reduce the plant's energy consumption and carbon emissions. The Hazel project, how we support climate neutrality, and where Dijana, the team in IECE, and Blas and the team in Slovenia have worked with us to look at that mission to convert knowledge and ideas in the field of hydrogen into projects and services of economic and social benefit. And in partnership with the Belfast Met Business Department, how we're looking at introducing business models to that field to make them more innovative. So it's not just R&D, it's R and applied development. To establish synergies and exploit complementary competencies of the participating industrial and academic organizations, enabling the sharing of knowledge through common research facilities. And importantly, to raise capacity of various industry sectors to apply research results and innovations in order to achieve low carbon, yet a more profitable economy. The Research Innovation Foundations and Models. Through Hazel, we're creating knowledge alliances. We're using one of the most promising models in research innovation to strengthen Europe's innovation capacity. We will develop new and innovative multidisciplinary approaches between industry and academia. We will stimulate entrepreneurship and individual innovation within the doctoral teaching to make sure we have those applied development technologies. And with our partners in Saarland and the ITSIS, we will achieve knowledge alliances, boosting innovation in higher education, creating the modified triple helix model, academia, industry, and society, and generate deployment of technological innovations through an open collaboration platform. Hazel is our new collaborative research model. It's a new paradigm, collaborating through research and in partnership. It creates industry academia collaborative R&D programs, and it will deliver strategic research innovative partnerships, industry-led, industry-driven, facilitated by academia, such as the specialization in Slovenia for that smart specialization that Blas will talk about, enabling technology transfers, boosting industry innovation capacity, and creating that innovation pathway. The Hazel innovative approach will bring ESRs to be trained as scientists, embedded in industry, delivering for industry, making sure that the PhD research has that development focus, and will deliver for industry, raising the industry R&I potential, establishing R&D centres, creating marketable industry projects through innovation, wider demonstrations of economic and social benefits, and therefore a greater and wider acceptance of models of research and the new models for financing. In conclusion, as we move down the pathway of innovation entrepreneurship within the new energy economy, there's still a lot to be done to increase and improve hydrogen applications in production, utilisation, storage, health and safety, and all of those different areas under the 4 key areas of Hazel. We need a systematic approach to integrate the whole energy supply and that consumption chain. Research and innovation will play a crucial role in hydrogen strategy, but it needs that new mix, that new energy paradigm we've talked about, where it's not just research for research's sake, it's research with a development focus. This is the key area that Mark Wells from our lead partner in GenCom Energy talks about. How do we deliver what industry need, what industry want, and drive industry through research and development and deployment? The D carries out development and deployment in industry. And how do we create those partnership and collaboration models between academia and industry through the common research innovation projects that bring benefit for all sides and result in market-oriented innovations?